Hello, everyone. My name is Michael Lee, and I'm a solutions engineer at DJI. Today, I'll be going over DJI Energy Industry Solutions with you. Today, these slides are to introduce the DJI drone solutions into energy industry regarding the different sectors like solar, wind turbine, electricity, utilities, and oil and gas. This is the potential of the drone usage in the energy industry. Why does it have such a huge potential? If you look at the report from the Drone Industry Insights, you can see the drone market is about $6 billion. Primarily, most common methods being inspection, but also mapping and surveying, localization, tracking, and others. Some clear advantages are saving time as it takes to complete a task. Because with a drone, it's a lot quicker to fly, safer, and also allows the human to be further away, increasing work safety. Previously, we would have to use the human eye to verify, but now with camera and very accurate GPS locations, we can improve the efficiency of the energy equipment. So some use cases I'll be going over today is electricity utility, mining, solar, oil and gas, and wind. So diving into the electricity utility side of things, inspections. Top use cases in electricity right now are inspections. Inspections include substations, transmission, and distribution. This is all done with visual and thermal cameras. They can also be automated and used during emergency response after disastrous events. Digitalization, this consists of transmission distribution lines, digitalized for vegetation management. This can be done with drone pictures to produce a 2D and 3D model. Some other use cases with drones are wildfire preventions, using the drones to inspect for any potential wildfire prevention, and also line pulling using the drone. So what is a distribution pole? Well, typically what's on a distribution pole can be various different pieces of equipment. So typically what you'll capture in a drone is insulators, some cross arms, lightning asserters, transformers, ground wires, primary wires, cutouts, neutral wires, secondary wires, telephone and cable, and guy wires. So this is all typical to see in the field when you're inspecting a distribution pole. On the right is also a popular workflow for a line inspection of consisting of 6 photos. A traditional workflow is to climb the pole and inspect it with the human eye. With the drone, this is done a lot quicker and faster with just 6 photos, and that can consist of thermal and RGB photos. This is some typical defects. The inspector can check these photos by human eye or throw this into an AI machine software to sort through the defects and severities. This can also automatically be performed analysis to see if anything is broken, overheating, or just even too much vegetation. So this is the Maverick 3 Enterprise and Thermal line inspection solution. This is showing both drones. The Maverick 3 Enterprise serves as more of a mapping and surveying inspections, and the Maverick 3 Thermal stands for thermal. The thermal is good for checking temperatures. But the key points of this inspections is that the drone has the capability of having 7 times optimal zoom to ensure a safer distance from drone to asset. There's no need for user to fly inside the pylon, and omnidirectional obstacle avoidance on the drone using its sensors. So some of these videos will display how easy it is to use the drone. It's as simple as pointing in the interested area and taking photos. Another solution is a fully automated solution. Typically with drones, there's a pilot that is on site flying the drone and taking photos. With the DJI Dock, which is a drone in the box solution, this eliminates personnel on site. A drone is able to deploy and inspect assets automatically. The box becomes the controller, and a software program called Flight Hub 2 manages everything. Another use case is 2D and 3D mapping. One is the point cloud that is based on LiDAR data processed in DJI Terra. This can give accurate geospatial data over the power lines. Another we have on the right here is we have another 3D model, but this is based on RGB camera and photos. This is going to give the power line customer more information of the surface information versus LiDAR 3D models. So on your left, that's produced with a LiDAR camera, typically an L1, and then on your right is done with a RGB camera. This one, I believe, is done with the photogrammetry 1, so the P1 payload. So both of these payloads are able to generate models. What you can do with the 3D model is one could typically use case is vegetation management based on point clouds. So this is a really good use case if you have the 3D model together with the power line pulling and the environments. You can easily manage the surrounding vegetation. This will give the horizontal distance between the tree and the power line, and also see the water coated distance between the tree and under the power line, so we can prevent potential fires. With this, you can clear the vegetation before things get worse. Going into the mining industry, so with the electrical and utility industry, the use case is typically taking photos and analyzing the picture, or taking the thermal image and analyzing it. With thermal, things are a little different. With mining, it's mainly surveying and mapping and geospatial. So that joint application overview is using the drone for asset lifecycle management. You can use the drone for 3D base map or 2D base map for the site for designing. This will be useful because every time you design, it will require maps. Also, some operational management. You have aerial surveying and 3D mapping. If there's any drilling and blasting, we can use drones during the blasting or drilling for additional data. Also, supply chain management. The drone can create 3D models and calculate volume of stockpile and inventory. The data is going to give a lot of useful information to the owner and the operators of the site. We look at the drawing above, the mining life cycle, especially from the design to the haul. We have several different use cases and reasons for drones to be in each part of the process. We'll go more into each and every single one of them, but just kind of like a high overview from the beginning to the end. With the design, you get 3D models of the terrain, digital twins, short and midterm design with better data and AI improvements, and then all the way to the end in the hauling stage, you're able to even create models from the truck routes and roads, identifying dangerous objects, also any truck damage detection. So going into high efficiency survey and mapping, this kind of displays the advantages of drone uses. Drones provide high efficient survey and mapping applications compared to traditional survey and mapping in the mining side. So traditional, if you take a look on the left side, traditional will take weeks. Detail is not always most accurate. Also require surveys to be in potentially unsafe environment and difficult areas to access. And then also the equipment, high costs of 3D laser devices. So you can, before even going into the drone side of things, you can kind of already tell that with the drone, does not take weeks versus hours. The information is detailed and very accurate, and humans never need to be in an unsafe area. You're able to create digitalized twins that are ready, and also the equipment with the drone is a lot cheaper than some of the traditional methods with the 3D laser device. Here we have an efficient base map solution. What DJI offers is that what DJI offers is that this is all done automatically with mission planning on our DJI application pilot app. Centimeter level accuracy with RTK to ensure accuracy, and then you also have high efficiency and high quality. Speed is the drone is able to fly 15 meters per second, and depending on which drone and payload, you can either have 20 megapixel, 45 megapixel camera and accuracy. During the drill and blast process, the drill design can be periodically updated with 2D and 3D models. Post drill, you can have a deviation report. So during the blast recording, videos can be used. Videos can be used from the aerial view for analysis. Um, Post blast 3D model from volume calculation, and 3D models can analyze oversized debris. So this is kind of the drill and blast process with drones involved. For stockpile management, with a very accurate 3D model, you can use that model for blast volume management to compare pre and post with accurate measurements. Stockpile management, manage input volumes, see daily, weekly, or monthly changes, and actually be able to track those surface to design. And then you have pit cut fill maps where you're able to have up-to-date whole site information for larger sites. So this is all done with a accurate 3D model produced with your DJI drone. And then we have high wall management, which is more of like a safety use case. With drones, you can use 2D and 3D models for mission planning, high quality 3D models, inspections and detection, and AI analysts to automatically analyze and detect high wall slope. So diving into solar, so if you look at typical solar projects, there's two, one being ground-based centralized and one being distributed. An easy indicator of size, typically ground-based centralized is massive and far away. Distributed are in factories, commercial buildings, houses, in different areas. So you can kind of see on the left side, there's all these solar panels, and then you can see distributed being on even in households, commercial and private. So you kind of see how drones are used for solar with different tools and use cases above. So you have site surveying and mapping. This is going to be possible with the LiDAR camera or photogrammetry camera and even a Mavic. The drone is basically going to be able to create point cloud models, and you can use that for project pre-evaluations, environmental condition, elevation, and slope. And then you have layout design, which uses photogrammetry to generate high accuracy models. And using these models, you can calculate number of panels, position, mounting angles, and all different sorts of data. And then you also have photogrammetry using engineering. You can use the drone to generate different DOM models and get live streaming on site and monitor progression throughout the event. And then operation and maintenance. So this is more of just overall keeping up with periodic maintenance. You can use different sensors, Maverick, drone in the box solution, where the dual sensor drones are working with third-party applications and softwares, and you can check hotspots, broken cells, bird droppings, and all sorts. So going into the DJI Enterprise solution, you have design and engineering. You have a DJI Mavic 3E and M300 and P1, M300 L1, so photogrammetry and LiDAR camera. You're able to capture data and put that into DJI Terra and FlyHub 2 also, and then a GIS design software. So that's a solution for design and engineering. For inspections, you have a variety of tools, drone in the box from M300s with photogrammetry, camera, or M30, DJI Mavic 3 thermal. You would fly it with your DJI Pilot or FlyHub 2, and you can get a report analyst platform. You can have autonomous data processing platforms, and then also a mobile app to locate any anomalies when you're out in the field and you want to actually address or fix that issue. So this is a design, or this is a use case from Loveland Innovations. This is a rooftop site design using the Mavic 3 Enterprise series and a third-party software. With those tools, they're able to basically reconstruct and measure. This is a rooftop of a residential building, and also works for commercial. And the drone is able to do model reconstructions and just get more accurate coverage area of the rooftop. So with the help of a third-party solution provider, the 2D and 3D reconstruction models are not only used to measure the coverage area, but also estimate shade data in the rooftop. Site surveying design. So with the M300 RTK and P1 or M300 L1 or DJI Maverick 3 Enterprise series. Combining that with our DJI Terra, our post-processing software, a DSM model can basically be processed by the third-party platform to generate contour lines. This can help to make your installation more accurate based on real terrain situation, and also help the engineering team to evaluate workload more fast. So this is topology information. Engineering and construction. So with the DJI Maverick 3 Enterprise and DJI Terra, the drone can be used for to construction stage to monitor an installation process and make sure that the project is in the right track. So some of these images, as you can see, are taken by the drone and then processed into a third-party platform using AI technology, resulting in a CAD design diagram to track engineering process throughout the process and installation. Aerial thermal inspection. So with aerial thermal inspections, you can adjust gimbal orientations, overlap ratio, and RTK connection. So these are some great tools to use. So camera position is typically set to let shooting perpendicular different components and ensures the strongest infrared reflection signal and a lot less information loss. You also have overlap ratio for better mission planning preparation, a lot less post-processing, and this is typically done in the setting reference and may depend on the customer or post-processing software. And then also we recommend RTK connection to ensure centimeter level precision. Aerial thermal data analysis. So with some of our tools, this is the M300 RTK with H20T or Matrice 30T with Maverick 3 Enterprise Thermal. So you can see it with hotspot detection. The DJI thermal payload can quickly identify various defects and accurately locate position through post-processing software. So we do have our DJI thermal analysis tool, and you're able to see any defects and present a PDF or report. Also on your right here, we have a AI thermal analysis tool. Each image carries POS information. So in the post-processing platform, we can detect any faulty nodes, and these nodes can precisely be displayed on the map. Okay, going into oil and gas. So top use cases in the oil and gas industry are oil field inspections, pipeline inspections, and process plant inspections. This is an example of oil field inspection using the Matrice 30 and M30T. You're able to get aerial operation, so you can quickly go through assets. The zoom camera is very precise, and you also have that thermal camera for night operation. And with this drone, it's super flexible and portable. The size drone can be fit in a backpack and is very quick, doesn't take much setup time, and has almost 10 miles image transmission in this oil field inspection environment. And then you also have multiple cameras. You have wide and zoom cameras, also waypoint missions to have autonomous missions, and then wide angle image and thermal images available also. Going into pipeline inspections, you have high efficiency for regular patrol, so you can quickly create 2D maps using the wide angle, one-time mission design, autonomous flight based on the pipeline, digital base map. So that's something that you can create autonomous flights. You also have multiple flight modes for efficiency and then reduce costs. So no longer is manned aircraft necessary, and you reduce manually outdated inspections with personnel potentially having to go out in the field when you can do this with the drone. So these are some process plant inspections. As you can see, some tools we have going right now is the one-click panorama. So it's able to create a panorama pretty quickly. Going into the Ultra HD matrix photo, which is basically a high resolution grid. You can drop that grid in an asset you want to inspect, and it will take full-size photos and generate that, as you can see. And then inspection route planning based on 3D models. So this is a 3D model that's created in DJI Terra, and from that model, you can actually flight plan and create missions that you want to inspect any assets. So by creating a 3D model, you can consistently flight plan. And then this is precise inspection by automatic flight. So this is using a different mode to essentially plan an autonomous and automatic flight and consistently get that same data. Going into gas leak detection. So with gas leak detection, if there's any high concentration of leaks, you can use the M30 and M300. And these two platforms do support third-party software development kit payloads. So you can have third-party payloads. So this right here is a U10, and it uses technology called TDLAS, tunable diode laser absorption spectrometry, and it's able to detect methane using a laser technology. And with that, it is able to generate a report, as you can see. So you have that option also. And then you also have this. These are called sniffers. So they are able to suck in gas and detect gas and also generate another report. So these are just some use cases for gas leak detection, third-party payloads that are available with our DJI drones. So that concludes today's slides. I want to thank you again and have a great day.